Hi friends, welcome to GMK Tutorials. In this video, we are going to discussing about the current mirror circuit is used in case of the common drain amplifier. Generally, in case of the common drain means that the drain terminal is common for both input and output side. So for that purpose, how we can use the corresponding common current mirror circuit in this configuration. Okay, so let us see here. This is the circuit diagram for this one. So this is a drain terminal. This drain terminal is a common for both input and output side. But in case of the drain terminal, the drain is a common where we are getting the drain current is a constant current. So that's why we are using in case here using a current mirror circuit. That is the basic reason behind it. So for that purpose, I can represent the color difference. This circuit is generally called a current mirror operation, where R bias is nothing but a biasing element for the M3 transistor. So this is nothing but this current is generally called as IDS2. This is also called as IDS2. So that means it is also a drain current IDS2. Okay, drain to source current IDS2. Okay, so here M2 and M3 transistors are identical characteristics, then only it forms as a current mirror operation. Okay, that is a basic analysis here. At the same time, just if you are representing in terms of equations point of view, the drain current VDD. So that means the VDD is equal to whatever the VDD, that VDD value is equal to VDD is equal to. So in this case, VDD is equal to total VDD. This is nothing but VDD is equal to the current passing through this one. That current is nothing but generally I reference current. Okay, that is nothing but I reference current into corresponding biasing value. At the same time, the voltage produced at the VGST that gives rise to VDD value. So therefore, from that you can reference VDD is equal to I reference. Just I can represent I reference into R biasing. Just I will represent R biasing plus VGS3. Sorry. So that is nothing but gate to source voltage at a M3 transistor. Therefore, this complete value in this direction that gives the VDD value. So that is the basic important here, right? So that is nothing but VGS2. At the same time, from the current mirror circuit, I reference is equal to ID3. Yes or no? So that means reference current is also equal to I reference is equal to IDS3. Drain to source voltage at the corresponding third transistor. That is equal to drain current formula is equal to KW3 by 2 into L3. So VGS3 minus VTH whole square. This is the formula in case of the drain current. Okay. At the same time, if you speaking, there is some non-ideal characteristics is also existing. Okay, if you are representing in terms of that one, so IDS is also can be represented as IDS2 is also represented as W2 by L2. That is nothing but the dimensions of the second transistor divided by dimensions of the third transistor W3 by L3. Okay, into I reference value. But apart from this, there is some another part is also there. This part is generally called the non-ideal part. So that part is nothing but like it can be represented 1 plus lambda into lambda VDS 2 to 3. So that means the difference of delta VDS, just I will call it the delta VDS is the variation of the, just I will represent neatly. So this variation is generally called as a delta into delta VDS 2 to 3. So 2 to 3 means the difference of two transistors. Okay, so that is nothing but this value delta VDS is nothing but VDS2 minus VDS1. VDS2 minus VDS3. So if you are taking approximately this value is equal to 1, approximately the difference is equal to 0 means just if those two currents are 0, we will get a very little difference or maybe approximately 0. So from that analysis, you will take this part is equal to some unity, so this part is equal to unity, then you will get only this part only. Okay, this part only. So this is nothing but 2. So IDS2 is equal to W2 by L2 into W3 by L3 into I reference. So that is the equation for drain current in case of the common drain amplifier case. At the same time, if you draw the small signal analysis, like whatever we discussed in the a common source point of view, if you draw the same small signal analysis for this circuit, just I will draw the small signal analysis. So this is a small signal representation for common drain amplifier. So this resistance is represents we can call all R02 R02. So this resistance is equivalent for current mirror circuit. This is the remaining part is for related circuit common drain. So GM into VGS1. So this is also called, I can call as a R01 resistance, because it is related to M1 transistor AC ground. So this is a equivalent small signal equivalent mode. So in this case, if you want to find out the voltage gain, so V0 by Vin is equal to GM1 into GM1 into, so remaining all values whatever they present in the circuit. So let it be see here, that is nothing but AV is equal to voltage gain AV is equal to V0 by Vin, that is equal to GM into by GM1 plus 1 by R01 plus 1 by R02. Because of R01 and R02 are high, it is approximately equal to 1 only. Okay. So this is a calculation for voltage gain in case of the common drain amplifier with the help of a current mirror. Very important criteria here is nothing but just only one important consideration. In case of the drain current is same, common drain, that's why just this part is replaced with only current mirror circuit. This part is replaced with only current. That is the only basic variation. Okay. So this part is generally called a current mirror circuit. Okay. The current mirror circuit basic purpose is nothing but we are using which produces a constant current source. Why it is important means that is there any variations in the drain current source? Obviously there is a lot of variations in the characteristics and all those things. So that's why we need to maintain a constant current source. Like already we discussed so many applications in terms of charging of the laptop, cell phones. If you are not providing a constant current source, the performance of the circuit is also maybe degraded. So that is a very important criteria. So thank you for watching GM Video. Thank you guys.